Welcome back. In this video, we're going to talk about build size. Today, we're going to focus on what is included in the build. What do you mean by reachability? What all assets are included in the build? And we're going to talk about compression, like how compression works in Unity. And we're going to discuss whether unused assets will be included in the build size. This is going to be full on theory. And let's dive in. Okay, welcome back to lecture 2. We are going to talk about build size. So, you may already know this. This is the output, the APK, the exe, the WebGL output of your game. That is the build size. Very simple as that. But what the build actually is it's a mix of the engine code combined with your code. So if you have things like rigid body and everything, that is all engine code. And your player movement, enemy scripts, AI will be your code. That's essentially the build. And the most important thing about the build is it is highly compressed. Highly compressed. Okay. So earlier we discussed that disk size is the raw file. Once we compress it with the import settings, we then get the size that is used in the build. I hope that is clear. Great. So references. This is why we want to talk about build size in a memory profiling course. We should talk about something called reachability. Okay. This is something that we talked about earlier in the intro lecture 0. This is not an official term. This is a term that I used so that it is convenient. Okay. Let's say you have a player and the player is loaded into memory. Okay. I hope that makes sense. When the game begins, player is loaded into memory. Is that how it works? So let's say the player is actually linked to a player prefab. Okay. For the player to be loaded, player prefab is loaded first, and then the player is loaded into memory. Now we can go even backwards. So what are the things that are present in the prefab? Let's say there is a mesh filter. This is a class. Let's say there is a movement script that is yours. Okay. So now I want you to think about the terminology. Okay. We talked about something called native and managed. Mesh filter is native. Okay. While movement is managed because this is your code. Everything that you have written is managed. Everything that Unity has written is native. There is no GC in native. There is always GC in the things that you have written. Okay. Now, mesh filter contains the mesh, right? Mesh is loaded through the mesh filter. And things that are referenced in your movement script are also loaded. Great. Now, what else could be there? There is also a mesh renderer, okay, that also exists in the player. Now, what does mesh renderer loads? It will load the material of the mesh. And what does the material load? It will load the shader. And you can see for each component inside your game object, anything that is referenced by it is loaded first. You can see that this list could go on. If you have, let's say, a particle system in the player, it will load the sprite, right? For the particle system, it will load everything that is needed for the particle system. This is what I mean by reachability. So you have a player, okay? And this player uses this mesh. Great. This is what reachable means. This mesh is reachable. But now I want to take this a step further. Now let's say this player spawns, okay? Again, listen to me carefully. Let's say this player spawns a weapon. Let's say there is a weapon script, okay, to the same player. But this thing is spawning it. And this thing is using addressables to spawn it. Okay, let's spawn a sword. And because it is loaded at runtime asynchronously, it is not directly referenced, right? This is not a direct reference like this mesh. This is an indirect reference. Okay, now this is very important because this weapon loads the sword. this sword is marked reachable. Okay, this sword is reachable, just like this mesh. This mesh is directly connected, while this sword is still reachable. And great. Let's say this spawns weapon holder prefab. Okay, this is also reachable, meaning when the player is loaded, everything else needs to be loaded. So now, just because we have loaded the player, everything else is loaded, and reachable is not loaded yet, but it is still reachable. Okay, let's say this spawns 5 seconds later or something, and then this thing is spawned. This is still reachable because there is an actual reference. Okay, inside Unreal Engine, there is something called the reference viewer. If you have worked with it, that will actually show you this thing literally. I hope there is a feature coming inside Unity that just like that. That is very, very useful. But this is how it works. Okay, if it is unused, but it is reachable, let's say this is referenced, but this is not spawned. Okay, this is not spawned. Still, it is loaded inside the build. Okay, this is just simply reference just for fun. That is also loaded. So you shouldn't add references just for fun. That will also be loaded. Okay, great. That is what I mean by reachability. Now, there is reachability through code. Like I said, this may be direct or indirect. Okay, while references through the inspector is always direct. Okay, things are loaded. In the code, if you are referencing, they are also loaded. This is very straightforward, but in the code, there can be indirect references. So there is a risk of not using references while we are working at code. If we are using things in the inspector, then it's a lot more evident. There is still the same risk of not using it. It's completely dependent on your code. But because we have assigned it or serialized it to the inspector, we will probably be using it. So there is less risk of it. So that is what references mean when it comes to build size. This is the rule. If an asset is unused and it is not reachable, it is not included in the build. If an asset is unused and it is reachable, it could be direct or indirect, it is included in the build. Okay? This is something that you need to learn. Okay? This is how you reduce your build size once you understand these things. Now, there are more intricacies when it comes to build. Okay? Things like static variables you need to be worried about. That is something in runtime memory, not a part of build size. So if you are working on a build and then the build size is high, you might want to look for things that are referenced indirectly. That may be one of the reasons. Maybe a high poly mesh and it's not being used. Or maybe it references something that uses a very expensive shader, but it's not being used. It could happen. Once you make your game big, things will get confusing. Okay? Maybe it's not the player, maybe it's a game manager or something that is not very obvious. Okay? You need to think about references if you want to think about build size. Okay? Of course, there are other things like compression and everything that will be important when it comes to build size. We can talk about compression. That's not something that I planned, but we can talk about it. So let's say we have a raw asset. Let's say this is 40 megabytes or something. It's a texture. When we build the game, it will be heavily compressed into a smaller version of the same asset. It could be like 2 megabytes. Okay. It is heavily compressed. Okay. This is in the build. Now, when we play the game, this is decompressed. Okay. It is the opposite of compressed into a slightly bigger, but not as big as the raw file. Okay. This is converted into a GPU compressed format. This could be like, I don't know, 6 megabytes or something. This is not as big as the raw file, but it still gives enough quality as the raw file, but it's still compressed. So this is how it looks with the import settings. But when we're building it, we are also heavily squishing it so that things are packed properly. I hope this makes sense. This is in runtime. Okay. So compared to the original, it is way shorter, but it still gives a good quality. At the same time, it is packed into the build in a much smaller way. I hope this makes sense. Now, let me answer why should we bother talking about this when it comes to memory. First of all, memory is not just about profiling, it's also about things like build size and disk size. But we have to include them when we talk about minimum spec requirements because the things in the build directly affect distribution, which is something that we'll talk about once we end runtime memory. So at the end of lecture 3, we'll discuss these things. Build size is very important for a game, but it's not the primary focus of this course. There are optimization techniques that we can cover later in the course, but it's very simple. And the final question is, should you delete unused assets? First of all, build size is less than your sanity. Okay. Prioritize your sanity over build size, especially if you are an indie team. Okay. Also, you should delete unused assets if there is any problem with the editor performance. It is very simple. Like if the editor is taking time to load, then you delete unused assets. If it is not needed, don't just keep them there. And finally, if you're working in a team, talk to the team and then make decisions accordingly. Okay, that is all for this lecture. We talked about compression and we talked about references. These two things are important when working with memory. I'll see you in the next lecture, which is about runtime memory. But you'll see me in a different dress because I'm out of time for today.